function. What is a function? A function is a relation, okay? But we need to remember, first of all, what is the definition of a relation? Relation is a set of ordered pairs that obey a particular rule. We can recall that. But now a function now is different depending on how you have your equation. So let's see. A function as a relation or is a relation in which each element in the domain is mapped onto one and only one element in the range. We have 1 to 1, many to 1. Okay, notice here 1 to 1 and many to 1. These are the two samples for a function that is also a relation. There is a function that's not a relation, which we will look afterwards. For right now, let's look at these two scenarios. What do we mean by a one-to-one element or relation? A one-to-one relation simply means when one element in the X is mapped onto one element on the Y. That is what we call a one-to-one relation, which is also a function that can work. That may be expressed as to say the function x is equals to x plus 6. Remember, this can also be said that way, or we can say x is mapped onto 2x plus 6. That's another way how we can say that. Now, this fx is the domain, this part of the equation is the range. So therefore, we can put it this way if we want to. We may go further and put now that the fx maps onto 2x, meaning the function of x is 2x plus 6. That's the next way how we can state this. Now take note of this equation. Okay, when we look at that equation, or this one here, which is a many to 1, this equation, remember this is in relation to the first equation that we did for a relation. Every element in the domain was mapped onto only one element in the range. In other words, no element in the domain was repeated and no element in the range was repeated. Everyone had one element to it, and therefore we call it a one-to-one relation. A many-to-one relation is what we are looking at now. So when we look at many-to-one, this is what happens. They will usually look like a quadratic equation. Okay, for right now, let's just look at it as a quadratic equation. Sometimes they give you a range and values for the x values which you will work with, so you can make a table. Now be careful here. When we put in an x value here, we get a y value. Okay, and again you do it this way: put x squared, 2x minus 5, and then we substitute 4x values. In this case, you will not add the 4 because the 4 is repeated here, so you will just only add these values here. And so we say 4 times 3, 12, negative 2 times positive 2, negative 4, negative, and then just subtract the negative 5. Then 12, negative 4, take away 5, and that gives us the 3. And likewise you do for the rest. Now when we put this in a mapping form, this is what we call mapping. This is the table format. We have the x, which is the domain, and we have the y, which is the range. We take the negative 2, negative 1, 0, 1, and 2. Notice here, negative 2, negative 1, 0, 1, and 2. When we put the y values, we put them right here. Now, in this case, you will only see one y value. So where did this 1 and 1/3 come from? So let me explain this piece here. When we have the negative 2, okay, you would usually get two values. Okay, and so you have to be careful how you substitute it. In other words, each one of these values here can have two values also. We are only expecting for one right now, so that you can see the difference, because whenever you put in a square, there are two ways we could get a squared value. Okay, so if you were put this as a square, then that will become another value. So let me see if I can bring out the pen here. Not the pen, draw. Okay, I want to use, see a dark color that you can see. Okay, that seems to be good. Okay, doesn't want to draw. Okay, so whenever you put this on a graph, because oh yeah, it comes out now, it doesn't come outside. Whenever you put this on a graph, this is your coordinates. You have -2 and you have y as your positive, as your, and 3 as a y value. So whenever you are -2 here, the y value is at the top, somewhere around here, just for right now. -1 and -4, -1 and -4, 0 and -5, 1 and 0, 1 and 0 right here, 2 and 11, 2 and 11 somewhere around here. Now, for simplicity's sake, when we draw this curve, they just roughly sketch. Okay, I'm gonna draw this curve now, and I come and I say -2, the x value of -2. We have two values, and -2 here. If you were to draw a line up, 2 right here, you can have it where it crosses the x-axis here, because it was specifically -2, and we have 3. This is only telling you what is the value whenever you have -2 and at the top, but it doesn't tell you the point where it crosses the x-axis. But any other point, so let me just move out from this point here, just in general, any other point in this graph, if I select a point here and I draw a line to meet the graph, okay, so if I draw a line to meet the graph, I will meet it there. If I take any value here and I draw a line this way now, there is a y value here and there's a y value here. Okay, so those two y values correspond to the same value that we have at the bottom. So therefore this will come right down here.